All right, so today we're going to talk about the line of best fit. Now, last year in 8th grade, you guys took out a ruler and you were estimating the line of best fit on scatter plots like this, right? You draw that line in and then try to figure out what the linear equation is for that line, okay? This year, you're going to find the exact line of best fit. So no more estimating. We're going to figure this out exactly. Now, your calculator will do that for you. So you don't have to worry too much about doing too much work. It's mostly just entering data, just like we've been doing. So let's look at this example right here. So this table right here shows the average and maximum longevity of various animals in captivity. So it wants me to draw a scatter plot to determine what the relationship is, if any, exists in the data. I'm not going to make you guys draw the scatter plot in, okay? But if you did, it would be like, it's always X on top and then Y when it's sideways, right? So you'd go to like 12 and then up to 25 would be like one piece of data. So something like that. And then you do that for each point. Each of these go with each other, right? This would be like the X coordinate, this would be like the Y coordinate. That's important for when you're entering in the data. Okay? And then it wants me to draw a line of best fit and write the slope-intercept form of the equation for the line of best fit. So this is where we can do it on our calculator. Okay? So to use my calculator to find the exact line of best fit, I'm going to go to data, and I'm going to enter in the data again. Now, clear the data that was already there. Here's the important part when we're entering this in. I've got an X and a Y set of data. So I'm going to have to enter in two lists. Now when I enter them, list 1 is going to represent all my X values. List 2 is going to enter in all my Y values. They have to match up. 12 would have to match up with 47. Okay? Because 1247 is a point on your graph, right? 12 and 77 is a much different point. Okay, so these have to be the same points across from each other. So you don't have to do them both at the same time. You can enter in all the X values, just make sure you don't skip any, or you're going to have to go back and start over again. So I'm going to enter in all my X values first. So 25, 15, 8, 35, 40, 41, 20. Okay, then I'm going to enter in on all my Y values. So I already entered in 47, so 50, 40, 20, 70, 77, 61, 54. Okay, now if you get on this last section and there's another number on this side than on this side, it's not going to work. You did something wrong when you're entering your data. Okay, for each X value there should be a Y value, otherwise it's not a linear pair. Okay, so once I have both lists entered, now I clear and I'm going to go to the stat menu, which is the second option. And this time, instead of going to one variable stats, I've entered in 2, but I'm going to go to the line of regression. That's another way of saying line of best fit. You'll see this AX plus B. Remember, the equation for a line is MX plus B. Calculator just calls the slope A here. Okay, but we enter in there and then just go through and go to calc. And again, it kind of shows you the equation right here, y equals ax plus b. So go to calc, and we have our slope is 1.2216. Like I said, it's the exact line of best fit. So we're going to just round that. So I'm not going to make you guys write that entire fraction down there. But to write that equation, this is the slope. A is the slope, right? And it kind of shows you right there, ax plus b. A is the slope, b is the y-intercept. So it gives you the two things you need right there. So the equation would be y equals 1.22x plus 22.45. Okay, that is the equation for the line of best fit. Now, next thing it wants me to do is use that equation to predict the maximum longevity of an animal with an average longevity of 33 years. Okay, in this example of extrapolation or whatever. Okay, so 33 years, so average age is the x values, right? So it wants me to replace this x with 33 and figure out what the maximum longevity would be. So if I replace that x with 33, I'd have y equals 1.22 times 33 plus 22.45. Okay, so again on my calculator, 1.22 times 33 plus 40 point, or not 40, sorry. I'm looking at my calculator, 22.45. Longevity would be 62.71. Okay, so again, this is kind of the beauty of stats, is with any kind of data, we can look at our average and max and stuff and figure out an equation that lets me kind of predict what something should be. Now, this only really works if it has a strong correlation coefficient. So one thing you're going to be asked is the correlation strong? Your calculator will tell you that too. If we scroll down here, this R is your correlation coefficient. The closer that number is to 1, the stronger the correlation. The farther or the closer it is to 0, the weaker correlation. So anything from like 0.6 and up would be a strong correlation. Anything from like 0.5 and down would be a weak correlation. This is a pretty strong correlation, so I can use this data to predict relatively well, because this data is showing a pretty strong correlation. The average range and max years in captivity. So, and again, if we look at our assignment and stuff, it'll ask us if what the correlation coefficient is. It's just asking for that R value. And then it asks if it's strong, weak, or no correlation. So weak would be like 0.5 to like 0.3, and anything close to 0 is, no correlation. Okay? But the closer that is to 1, it only ranges from 0 to 1. So it's not like it's ranging from this wide value of numbers, but it will range from 0 to 1, and again, the closer it is to 1, the stronger it is. And you can think of that as like a percentage. 1 would be 100%, right? 88 is 88%, so that's an 80% correlation there. So pretty good, pretty strong. And that's basically what you're doing for the line of best fit.